Hello everyone. Through this video we are going to discuss some important questions of exercise 11.3. So here goes exercise 11.3. The first question is an important one. Here what is given, there are two cuboidal boxes as shown in the figure, in the adjoining figure. Which box requires the lesser amount of material to make? So the figures are given like this. One cuboid is given. This is the cuboid. This is the cuboid given to us. Here in this case, the length is given to be 60 centimeter. This length is given to be 60 centimeter. Then the breadth is given to be 40 centimeter. And the height of the box is given to be, means this height is given to be 50 centimeter. This is 50 centimeter. At the same time, a cube is given with edge length 50 centimeter. This is the cube given. The cube is like this. This is the cube. Height is 50 centimeter, means edge length is 50 centimeter. So here in this case, what is asked, which box requires the lesser amount of material to bake? So in other words, we have to find out the total surface areas of these two boxes, and that will help us to determine the materials required for each of them. So first case, this is A, this is B. So for A, what do we have? Given cuboid has length L equals to 60 centimeter. Then we have breadth small b is equal to 40 centimeter. Then after height h we have as 50 centimeter. Therefore total surface area of the cuboid is equal to, we already know the formula, twice LB plus BH plus HL. So here in this case we have to put the respective values. In place of L there will be 60, in place of B it is 40. Here again the value is 40 into 50. Then after, next we have 50 into 60. Unit will be centimeter square. So here in this case 2 into, within the bracket what do we have? 2400 plus 2000 plus 3000 centimeter square. So after this what do we have? After this, on calculation, we shall be having 2 into, while summing up, the result will come as 7400, of course, 7400 centimeters square, and the total surface area we are going to get as 14,800 centimeter square. So total materials required will be, therefore the material required for cuboid will be what? 14,800 centimeters square. Then we shall come to case B. Given cuboid, in this case given cuboid has edge length say L as 50 centimeter. Therefore, total surface area of the cube, I'm sorry, here it should be cube actually, not cuboid. Here, since all the edges are equal, therefore here we have to consider cube. Therefore, total surface area of the cube is equal to 6L square. So what can we write here? Next, 6 into 50 into 50. I have broken the square. The result will come as ultimately 50 into 50, it is 2500. By 6 if we multiply, it will be 0, 3 is left, so 15,000. The result comes as 15,000 centimeters square. Therefore, the materials required, therefore the material required here is equal to 15,000 centimeters square. Here, of course, the material required in case of A is lesser than that of B, lesser than that of B. So this is the answer. Then we shall come to question number 2. Here is question number 2. In question number 2, what do we have? A suitcase with measures 80 cm into 48 cm into 24 cm is to be covered with tarpaulin cloth. How many meters of tarpaulin of width 96 cm is required to cover 100 such suitcases? So in this case, first of all, we shall try to find out what is the total surface area of the suitcase. And of course, that is cuboidal in shape. Given measures of the suitcase are, how do we write? 80 centimeter, or just we can write R, length L. This can be taken as 80 centimeter from the measurements. Then breadth B is equal to 48 centimeter. Then after height H will be taken as 24 centimeter. So here what do we have? Total surface area of the cuboidal suitcase will be equal to twice LB plus BH plus HL. So this is the way we have to consider 80 into 48 plus 48 into 24 plus 24 into 80 centimeter square. So while calculating the results, we shall be getting as 0 here, 8 8 just 64, 6 left, 3840. Then after, in the next case, in the same way, after calculation, we shall be getting result as 1152. In the third case, the result will again come as 1920 centimeter square. After this, we shall be getting the sum of these three things within the bracket as 6912. 6912, and the results will come like this. 13,824 centimeter square. Here also it is centimeter square. So this is the total surface area of the suitcase. Then we are going to cover the whole box by tarpaulin cloth. So according to question, area of cloth will be equal to area of, or we can say total surface area, that will be much better. Total surface area, that will be TSA of cuboid. So we can write here area of tarpaulin cloth means length into breadth, of course, because it will be rectangular in shape, yes or no. TSA of cuboid we already got as 13,824 centimeters square. So after this, what do we get? We actually have the width of the tarpaulin cloth, or breadth we can say, as 96 centimeter. So we can write here length into 96 centimeter is equal to 13824 centimeter square. So this centimeter will get cancelled with one of the centimeters. So length will be equal to 13824 by 96. So on cancellation, the result comes as 144 centimeter. So here we get the length of the tarpaulin cloth as 144. Length of tarpaulin is equal to 144 centimeters. So we have to find out the total length of tarpaulin cloth required for making 100 such suitcases. For one, this is the result. Therefore, for 100 suitcases, the length of tarpaulin required is equal to what do we have to do here? This length means 144 should be multiplied by 100 centimeters. So it is 14400 centimeter. Don't you think that we can convert this into meter units? So divided by 100 meters. So the result will come as what? On cancellation, it will be 144 meters. Now, yeah, this is the required answer. Just we need to find out total length of tarpaulin. So this is the required answer. Next, we shall come to question number 3. What is said here? Find the side of a cube whose surface area is 600 centimeters square. So in question number 3, what is given? Or just before that, we shall be writing one more thing. Edge length of the cube is not mentioned here, so let's consider that first. Let the edge length of the cube be L. Given surface area of the cube is what? surface area of the cube is given to be 600 centimeter square. So surface area of the cube means total surface area only. So formula is this one, 6L square is the total surface area of the cube. So 600 centimeter square. So after this we shall be getting L square equals to 600 divided by 6 centimeter square, to cancellation, this is 100. So after finding out square root of 100, we shall be getting the edge length to be 10 centimeters, and this is what we need to get. Therefore side of the cube, we can consider side length or edge length or side also, no problem with that. So side or edge length, side of the cube, L is equal to 10 centimeters. So this is the answer. After that, coming to question number 4, what is given? Ruxar painted the outside of the cabinet of measure 1 meters into 2 meters into 1.5 meters. How much surface area did she cover if she painted all except the bottom of the cabinet? So let the cabinet be given like this. This is question number 4. Ruxar is doing what? She has painted a cabinet. So cabinet looks like this actually. A rough sketch I am drawing. This is a rough sketch of the cabinet. So here in this case I am having 1 meters, 2 meters. 1 meter is the breadth, of course, 2 meters is the length, and height is 1.5 meters, suppose 1.5 meters. She has painted all the other surfaces except this bottom one. Means whatever total surface area we shall be having, actually this is a cuboid in shape, its total surface area is twice LB plus BH plus HL, but she has left the lower surface. So the lower surface measurement, area measurement will be of course LB. Therefore this putting the respective values here in this particular expression, we shall be getting the required result. So what are the things given here? Given cabinet has length L is equal to 2 meters, then breadth it is having as 1 meter, then height, its height H is equal to 1.5 meters. So after this what we shall get? Surface area of the cabinet painted. Therefore the surface area of the cabinet painted, that will be equal to, from the total surface area LB plus PH plus HL, we are going to subtract one surface. So ultimately what we shall be getting, after putting the values, in place of L we can put 2, in place of B it is 1 into 1.5 plus 1.5 into 2 minus it is 2 into 1. So the whole thing centimeter square, sorry, it is meter square. So after this what we shall get, on calculating, after calculation what we shall get, this is 2 within bracket 2 plus 1.5 plus 3 minus 2. meters square, the first result will come as 2 into it is 6.5 minus 2 meters square, so it is 13 minus 2 meters square, the result will be 11 meters square, and this is the required answer. Next we shall come to question number 5. In question number 5, what is given? In question number 5, Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height of 15 meters, 10 meters and 7 meters respectively. From each can of paint, 100 meters square of area is painted. How many cans of paint will she need to paint the room? So in this case, first of all, we are to consider 5 surfaces of the hall. 5 surfaces means including 4 walls and the ceiling. The floor is excluded. So this question is something similar to previous question only. First of all, the total surface area of the hall we need to find out, where the painting is done, where the painting is completed. Only those walls and ceiling we need to consider, excluding the floor. So whatever surface area is painted, that should be divided by 100, because per 100 meters square 1 cane is used. Therefore total surface area painted should be divided by 100, then it will give us total number of canes. So here in this case, given the hall has length L is equal to how much it is? 15 meters. Then breadth B, it has as 10 meters. Then height H is 7 meters. Therefore total surface area of the hall where painting is performed, or where painting is done, that is equal to twice LB plus BH plus HL minus LB, because the floor is excluded, therefore it has to be subtracted. So on simplification, or just after putting the values, what we shall get? 15 into 10 plus 10 into 7 plus, here in this case we shall be having 7 into 15 minus, it is 15 into 10 meters square. So let us check how much we get. 150 plus 70 plus 105 minus 150 meters square. So after this, 2 into what result we shall get? 32 minus 150 meters square. So after this, what result we shall get? Minus 150 meters square, it is equal to 500 meters square. Since each cane can cover 100 meters square, Therefore, number of canes required. Therefore, number of canes required will be equal to, this is the total surface area where painting is done, divided by total surface area covered by one cane. So the result will be like this, it is 5. So there are 5 number of canes required. So this is the answer. Then question number 6 can be done just by following the formula for cylinder and cube. So next I'm proceeding to question number 7. Question number 7 here. In number 7, what is given? A closed cylindrical tank of radius 7 meters and height 3 meters is made from a sheet of metal. How much sheet of metal is required? So here in this case, what is given? A cylindrical tank is given. So of course it is closed, it is given as closed cylindrical tank. So since it is closed, therefore the total surface area we need to find out here, because all the 3 surfaces of the cylinder will be covered by metal. So this is the figure, say this is the cylinder, 3 surfaces are there. This is the upper circular base, upper base, lower base, both are circular, and this is curved surface. So total surface of these 3 surfaces we need to consider here. Radius is this one, this part is radius, this is called radius, and this part is called as height, from center of the upper surface to the center of the lower circle. This is called as height. Given the closed cylinder has radius r is equal to, radius length is given to be 7 meters, then height h is given to be 3 meters. So we need to find out what? Total surface area of the cylindrical tank. Therefore total surface area of the closed tank, the formula is 2 pi r plus h. Now let us put the respective values. 2 into value of pi we already know as 22 by 7, r is 7, then again here it is 7 plus 3, unit will be meter square. So in this case what do we have? These two are getting cancelled. So 44 into 10 meter square, the result will come as 440 meter square. So this is the answer. After this, in question number 8, what is given? The lateral surface area of a hollow cylinder is 4224 centimeters square, means curved surface area. Lateral surface area or curved surface area means the same. It is cut along the height and formed a rectangular sheet of width 33 centimeter. Find the perimeter of the rectangular sheet. So what do we have here? A hollow cylinder. This is question number 8. We have a hollow cylinder. Say this is a hollow cylinder. A hollow cylinder we have here. This is a hollow cylinder. The upper part, no lid. It doesn't have any lid, and here also no bottom. So only this surface is there. So only the curved surface is there. So if this curved surface is, suppose it is cut at this position, if it is cut and it is just open it up in such a way that we are getting, after placing it horizontally on a plane, we are getting a rectangular sheet. Means after cutting it into pieces, here only one piece, just we are opening it up to get this type of rectangular sheet. So in this case, curved surface area is given to be 4224 centimeters square, which is getting converted into a rectangular sheet. Here we are having 33 centimeter as the breadth. Okay, length till now is not known to us. So don't you think that curved surface area of this hollow cylinder is equal to the area of this rectangular sheet? Yes, of course, yes. So how do we have to proceed? Given lateral surface area of the cylinder is equal to 4224 centimeters square. When cut along the height, we get a rectangular sheet of width, or we can say breadth also. Breadth equals to 33 centimeters. So according to question, what can we write here? No, just before that we need to consider, let the radius of the cylinder be r. Okay, so what do we have here? That r, actually curved surface area will be 2 pi rh. If this part is height, this part will be acting as the breadth, means 2 pi r. This part will be the length in case of the rectangle. So what do we have? According to question, CSA of cylinder equals to 4224 centimeters square. So what can we write? 2 pi rh is equal to 4224 centimeters square. Since the width is given, this width acts as the height of the cylinder here. So here in place of h we can write, means this can be taken as height also. So what do we write here? Let us write little in this way. It will be height of cylinder. So cylinder h, that is. So we can write here 33. So 2 pi r into 33 is equal to 4224. So let us write down the value of pi. It is 22 by 7 into r into 33 is equal to 4224. Next, what can we write? R will be alone here. Then 4224 into 7 divided by 44 into 33. We shall have to cancel it out. So after cancellation, what means, let us first proceed with the later part. Value of r we can keep like this also, or after cancellation we shall be getting this result. Reduced format I shall be giving you here. R will be equal to 64 into 7 divided by 22 centimeter. So value of r we are getting like this. So the length of rectangular sheet, length of the rectangular sheet will be nothing but 2 pi r, means in the formula 2 pi r h. If this acts as the breadth, of course this will act as the length, yes or no, for the rectangular sheet. So 2 pi r, it is 22 by 7 in place of pi. Here it is 64 into 7 by 22 centimeter. So these two got cancelled, these two got cancelled. We are getting the result to be 128 centimeter. So this is the length of the rectangular sheet. Therefore perimeter of the rectangular sheet is equal to twice length plus width. So what can we write? Length we got as 128 and width I got as 33, which is already obtained, centimeter. So 2 into, what do we get? 1, 15 plus 1, 16 centimeter. It is 322 centimeter is the answer. So the remaining questions, question number 9 and 10 of this exercise, can be done in the same way as we did all the sums. Thank you.